Hello, it's Scott Manley here, and today I'm going to do a bit of a live challenge. Now, what the challenge is something I just kind of came up with. The idea is to fly the shortest space mission possible. Now, by shortest, I mean the least amount of time from launch to landing on the mission clock. And by space mission, I mean that you have to actually go to space. So, you have to get to space and then get back to Kerbal as quickly as possible. And so here is a very simple example of what I'm thinking about. So we're using a rocket to more or less fly straight up, because of course that is the fastest way to space. And once we get there, we're going to turn around and come back. So there we got a mission to about 70 something kilometers. There we go. And going straight up, letting gravity slow us down. But you know what? We can probably make sure that we are ready to come back by pointing the rocket downwards. Just checking on the map to make sure I beat 70 kilometers. Point everything straight down. 63, 4, 5, 6, 7, 8, 9, 70 kilometers. We are in space. So it's time for us to head back as quickly as possible to our launch site, and therefore clock in and get home and call it the shortest workday ever. Not that Bill is a work-shy astronaut or anything, but it's just because he wants to get that particular record. Now obviously in the real world you would only go up and you would let gravity pull yourself down, but for maximum speed you want to be coming down as quickly as possible. I wonder actually whether this design will burn out all its fuel before it hits it gets to the ground. Either way, we do have a parachute which should let us get out of this thing relatively unscathed. You never know, it could be kind of dramatic. Okay, 2 kilometers per second, more or less, straight down. We can pretty much rely on the atmosphere to slow us here. Okay, and I'm going to turn that off. Ditch the capsule. Look at that. Brilliant. It is kind of awesome to behold this kind of thing. Now, of course, when the parachute opens below 500 meters, we will then float slowly to the surface. So another part of optimizing this is that we want to open our parachute at the last minute, which means there's a great potential for smashing into the ground at ridiculous speeds. We like that kind of thing in Kerbal challenges, don't we? 1300, 1200, 1100. This is where having Kerbal Engineer could prove useful. It means that you'd be able to bang. Hey, brilliant. Okay, and so that's like just under 358. 358. Now, can we go faster than that? Well, of course, that's what the challenge is. Okay, so how do we optimize this design? Obvious way is to start with bigger boosters so we accelerate faster. That's always a good way. Getting up there is important. Getting up there quickly is especially important. Let's actually make 6 of these just for good measure. Oh, or 8 even. Yeah, 8. That's always better. Now, we have this rocket here. What I could do probably is throw a bunch of this away, and we could probably get rid of those. What we can do is get rid of the separator, or at least move the separator elsewhere, and instead of having rockets instead of turning ourselves around, we can have rockets that add the deceleration built in there. 8 of those? Oh, why doesn't it want to let 8 of those fit in? 6? Does 6 fit? Yeah, 6 fit. I'm not sure. Why can't I fit 8? Yeah, thank you. 8 of those. That's exactly what I wanted. Okay, so we can ditch that. We can put a separator on there, except for this whole thing. We can put the separator on there. Bingo. Try to fit that in somewhere. Oh. This is the fun thing with doing live challenges. Okay, let's rotate it so I can actually see where my attach node is. It's in there somewhere. Why does it... Ah, there it is. No, come on. There. Gosh, such trouble sometimes. Okay, so now we shouldn't need to turn this thing around. Okay, so what do we have? We have the main engine. We have these things here. And we have a separator, and we have engines. Those 8 of those engines, which we can fire right away, although we probably don't want to fire them right away. And then we can come homewards. Okay, let's try this. A little bit of design work here just to optimize it. We want to get under 358. 358 is the golden standard now. Okay, so we are ready to go. Fire up stabilizers, fire up the engine, and off we go. So I'm going to double up the speed on this. We have the speed, the power of all those heavy solid rocket boosters there pushing me upwards. And I'm just watching the numbers on the solid fuel go down. I'm going to slow down time just before we ditch these things because it should make things... Ah, there we go. Darn, took too long to dump these things. Another important thing to realise is we probably should make sure we're going over land. I guess you could optimize this by picking a slightly higher piece of land if you were really, really smart. Okay, and that's that engine ditched. Oh, let's ditch that there. And how high are we going to go? We're going to go 103 kilometers. Okay, brilliant. I'm just going to turn this sideways. And actually, I should probably turn it that. Wait a second. Yeah, that way. I should probably point the rocket that way. Fire the engines. Oh, no, don't bump. That's not what I meant to do. Okay, well, I'll send that one back to the drawing board. You know, I think actually the problem is that my main engine should all be around that, so that when I start firing those, I don't have to worry about clearing the wreckage. Let's go back and let's just completely abandon this concept. We've already had enough comedy out of this. Okay, throw that away. And the only engines we have that will be anywhere near good enough for this are perhaps these big external boosters. Now I've got to attach these again by radial decouplers. We can stick 3 of those on. Why not 3? Actually, you know, if you're going to do 3, you might as well do like 6. I know this is a large part, so we know that 6 should be doable. I suspect that's going to explode as soon as it detaches. But that's fine because it means the debris will be cleared. Let's go for it. What have I got to lose other than my respect of the world of people that play Kerbal Space Program? Okay, ready, and throttle up. He can't even see where he is going. He's in the middle. All I can see is giant fuel tanks everywhere. I can see the altimeter though, shooting upwards here. Look at that thing go. Vertical speed is fast. Everything's fast. Vertical speed is fast. Fuel flow is fast. Survivability is low. Okay, so I gotta look at it from this point of view because I gotta know when to stop the engines, I guess. Ooh, and there. X, cut my engines. And I'm now decelerating. Gotta make sure that I continue with enough velocity to get above the atmosphere before my fuel runs out. 77. Am I high enough yet? 35 kilometers. I think I must have enough momentum. Okay, so I'm gonna ditch this stuff. Ready? Ah, totally works. Look at that, beautiful. It is like art in motion, you see? NASA could not do better. Of course, all those things will get spread around to their various landing sites. It's like a Merv. Look at them delicately pirouetting away to their ultimate demise against the surface of Kerbal. Okay, so I'm running time acceleration so I can get past the 70 kilometer mark. 8, 9, and there we go, throttle up, and now we're going to go down using the same engines. So that's the 2-minute mark. Now that means we have just under 2 minutes to get back to Kerbal, and we are at least going downwards quickly. We collected our all-important space data. Now it's time to collect our all-important space check and go home to the space wife and space kids in my space home on space planet Kerbal, or something like that. Okay, 2 minutes 45. fuel is burning, as fuel has stopped burning rather. 3 minutes! Okay, this is going to be faster. Partly, well, mainly because I use bigger and faster rockets. Now the last important act here is to fire up the parachute at the last minute and slow my descent to something manageable without slowing my return to something that will make me have to spend more time filling out reports and mission reports and timelines and things like that. 325. Okay, gotta look for that shadow. We're almost there. Come on, come on, come on, come on, come on. Ah, brilliant! Where's the rest of the debris? What a brilliant mission. That was just about 330 something, but I think I can do better. Of course I can do better. That's part of the challenge, right? And I'm going to open it up to entries from other people if they want. Let's revert flight back to vehicle assembly. Okay, so what I like this idea. I like the fact that everything just bounced off so elegantly, but what I'm going to do is make this fuel tank longer. I think if I do that, it might help. So I can come back faster. Certainly not lacking in thrust to weight ratio here. So 6 of these once again. You know, I wonder. I know. I guess the attachment point is there regardless. So that might make things faster. And then could I do something else? I'm just wondering. What I could do. Here's a crazy plan. Actually, here is a crazy plan. Okay. I think part of the thing is I need more thrust to weight ratio here. So what I should really be doing is having these solid rocket boosters pointing downwards or pointing upwards, right? So this will be my kind of initial arrestor system to slow me down. There we go. And then that's the rest of the system. And around that, I'm going to add a couple of big engines. These ones are nice, but they're not big enough. I think we have to go bigger. I think we have to go as big as the game will let us. Ooh, that looks good. I'm liking how this is looking in a kind of bizarre way. Okay, so solid rocket boosters not going to be on there. We're going to make sure everything fires in sequence. So we have this has to be on its own stage. That has to be there. Okay, wait a second. Move these onto separate stages. So that is ditch the main rockets. Then there's a button to fire these and fire these engines. And then there's a button to ditch those and there's a button for the parachute. Okay, we are set for our epic shortest mission ever. Shortest space mission. The important thing is you have to go to space. That's what makes it hard. You have to get up there as quickly as possible. Now, the other thing that I've been doing, which I could work on, is I'm kind of just going up to 70 and falling back down. I should just keep the engines going and then try to decelerate as quickly as possible as well. So keep accelerating until I get faster and faster, and then start firing these engines to immediately begin slowing my acceleration. So I should just let my velocity go up, 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 and not bother about ditching these rockets at all. Okay. I'm not sure the acceleration on this is as fast as I would like. Oh, darn, time acceleration hits again. Okay. Let's revert flight to launch. I'm getting so, I'm getting a little bit antsy here. Okay, let's try that once again. No time acceleration this time. Nope, you're just going to get the pure unfiltered experience of Bob Kerman riding this bizarre rocket. Feeling 2G's acceleration right now. That's not altogether too bad, to be honest. I like how the forces of this thing and those terrible cheap decouplers which I've used to keep them far from the body are bending the spacecraft out of shape. We're generating 6,400 kilonewtons of thrust upwards. Our engines are almost overheating. And so far, we're in the 12-kilometer mark. That is not necessarily the fastest launch, but perhaps I am confused because I've done all the previous launches under the power of time acceleration. Okay, 5 kilometers. How am I going to do it? I wonder how fast I should go before I ditch this stuff. 20 kilometers, and we're definitely above the atmosphere, but the point is we're still going to be going really fast when we tell it to stop. There we go. 300, and you know what? I'm going to ditch. Oh, darn. Once again, oops. At least he's got a parachute. He'll survive this. Okay, revert to launch. Once again, let's try this. Note to self, ditch... cut the power before we run out of fuel. I'm going to do that. I'm going to cut the power before we run out of fuel. Oh dear, the comedy of errors. You see, this is what happens with the live challenges. Nothing quite works. This is not how NASA does it, right? They don't put a bunch of people in a room and say build a rocket and then that's their space program. It would be fun to see if that happens there. Maybe some prizes that might come out of this might fit their, you know, faster, cheaper, spread over a wider area program, right? Okay, watch the altitude increase once again. Maybe the Russians did that, I don't honestly know. It does certainly seem that there have been a bunch of crazy ideas that can only have come from overworked engineers getting given a lot of money and asked to come up with awesome ideas for the space program. You know, I always like to point out about the lunar escape system and man out of space easily. That's those are two classic Kerbal inspired designs if ever I saw them. Okay, let's throttle back now. I'm gonna throttle down and just ditch this. Okay, how are we doing? We're going really fast upwards. Okay, so now I'm going to start decelerating at about here. Sure, that should work. We should be able to decelerate before we hit 70 kilometers. Okay, so the problem is we got to judge this perfectly. We've now reached the 70 kilometers pretty quickly. The trick is we're going too fast, actually. Oh, and you know what? I should fire up those engines as well. Yeah, I'm burning fuel decelerating. If I had done this earlier, I might have turned around faster. Okay, so now we've turned around, it's the 150 mark. The question is, will we get to the surface faster this way? We are... time to beat, I guess, is about 3:30 something. I didn't actually look, which is slightly problematic. Okay, and I can actually fire up time acceleration here now, since this is a far more stable and less likely to disintegrate piece of hardware. Okay, falling downward at 2 kilometers per second. Good thing that atmosphere is hard. Okay, 237. Will we beat the 3-minute mark? Who knows? But you know that even if we do, there is room to optimize this thing. Okay, come on. We're still gonna land near the space center, so at least we'll recover this for maximum profit or whatever. 254. Come on. No, okay. The atmosphere here is really slowing me down. It would be nice to have some like jet engines pushing me downwards for this last section, just to make sure I continue to go in as quickly as possible. Ah, brilliant! Oh no, he died! He died! That would have been so fast, but I opened the parachute too late. This is what happens when you don't plan these space missions. Okay, look, I think we can do faster. I think we can do faster here because there's still options to accelerate. Revert to vehicle assembly building. Okay, so how can I do faster? Well, first thing, let's actually get rid of this and replace it with the lighter capsule, right? Okay, so we're going to put on the Mark II lander can, and for parachutes, we're going to have these radial parachutes. I'm just thinking, like, if I have an engine, a jet engine, you want it to be on the middle because you want it to fire up when it's totally... you want it in the middle so that it doesn't go asymmetric and spin you out of control. But, all the same... Just trying to think what to do here. Okay, well, we definitely want radial parachutes wherever those are. Yes, we want radial parachutes. And we can put like a jet engine on here. Where is it? We'll put like a separator. That's what we'll do. We'll put a stack separator on. Stack separator. Or stack decoupler. It doesn't matter what side that's on. We'll put a tiny... the idea is this will have a jet engine to slow me down, or to, sorry, speed me up through the last moments in the atmosphere to make sure that I don't end up going down too quickly. See, optimizing the design for the regimes available to me. Okay, there we go. That's that, and of course we can fit some radial decoupler thingies into this, or not radial decoupler, radial well, yeah, we need radial parachutes because we want to make sure it slows down. That works. Okay, so that'll fire, and we're going to need air intakes as well. Maybe I should lengthen this just a bit. Uh-oh. Yeah, we'll get some room for that so we can put in our air intakes. And since this is going to be detaching seconds before I reach the surface, I'm going to put a little, like, Sepatrons on here. The idea is that those will push the thing off in its own direction and we will be safe. Where are my Sepatrons? My Sepatrons of power. Okay, there we go. And we want to turn... oh no, wait a second. If I do that symmetrically, it's not going to work. Got to put these on without symmetry so that I can turn them. I'm going to do like that. And on the other side... come on, come on, come on. Yeah, that'll work. So that thing should shoot off at the last minute. Okay, so we need some decoupler, not some decouplers, we need some air intakes here. Brilliant. Okay. We've got to make sure these things actually catch the air and decouple. That's very important. And we want this thing to fire up early before it's really deep inside the atmosphere. Okay, so the next thing we want is this rocket here, which I think we've definitely agreed upon as it's good to have these little radial engines here. So I'm going to do that. Although maybe I should put some of these cubic octagonal struts just to move the thing away from the rocket. I'm not sure if the collision mesh will be right, but I don't want those things not working in the face of sheer power. There, I think that'll work. Let's actually just check our staging here. We've got a stage that needs to fire at the last minute. So that stage needs to fire these parachutes and these decouplers. Not these decouplers, these things. They'll all fire at the same time, basically. I just want to make sure these Sepatrons, the main purpose of these is to make sure it doesn't hit this thing and destroy it, right? Okay, and then seconds later, okay, so before this fires, we're going to have these engines firing. In fact, this engine is going to fire... you know what, I could just fire up this engine at the same time as I fire these ones up, because it's not going to actually start working until we're deep inside the atmosphere. Okay, so... so yeah, and then we have a pair of parachutes that open at the last minute. Okay, now the trick is getting this contraption up to altitude. You know what, I think actually, now I think about it, I'm going to need more of these. Can I do that? Yeah, that should work. That should totally work. So I'm going to double my acceleration early on in the atmosphere. And then we'll put some more fuel here. And because we've got all this extra mass, we're definitely going to have to think in terms of building out, modular girder segment type things. Here, that's what I'll do. Put a couple of these in. Oh yeah, this is totally looking like it's for the win. Or at least for the destruction of something awesome. Yeah, same here. Couple of these. Might have to actually use struts on this design, to be honest. This is looking a little heavy. Okay, so Rockimax solid rocket boosters pointing downwards. More. Oh, that is not what I had in mind, sir. There we go. I'm not sure how that decision is taken sometimes, but I want to make sure it makes the right decision. We should probably put some struts on this. Strut. From there to there, and just hold this thing from, you know, pushing against. Okay, so these two, they have to fire on. Actually, these can fire at the same time as all those engines again, but the separator needs to happen here, and then this separator needs to happen before we fire those engines. Okay, and then we're going to need some really big engines on the side here, and I think we've established that we're going to need more power here than I was originally getting. So perhaps the way to go is, we'll go with these Kerbal engines. Oh, we'll get like 8-way symmetry, not what we want. And again, hit that. Oh, there we go. Except I'm going to need more power than that, because there's not really... I'm struggling early on in the atmosphere and could use more thrust. How best to deliver that? Well, I guess I could just take these things and double them up, right? Let's do that. Oh yes, I see a great future. You have a great future, young man. If you can hold yourself together while thrusting at maximum speed, then you will be a man, my son. Okay, this is definitely destined for greatness. And then connect this up here. Oh, look at that. How can that not be a thing of beauty? This is just bizarre. This is totally going to fall apart, you know. Okay, and we'll put some struts between these to try and hold it together. Okay, so these engines, where are we? These, why are these things on that stage? Those should be down the bottom. Come on down here, chaps. We're gonna ditch you first. Oh, don't worry, it's just a few hundred, it'll just be 100 kilometers, so at least when the speed you're going at, you unfortunately will continue upwards. Okay, this is my final challenger, I think. This is the, assuming the staging is right here. Let's go. Oh, there, look. The power of those struts being held, or holding those rockets in place. Struts are winning. Let's actually just turn myself ever so slightly to the east. Look at this thing go. Oh yes, 128 million newtons of thrust. Or wait, sorry, it's not 128. Yeah, no, 32. Yep, that's pretty good. 12,800 kilonewtons, or 12.8 meganewtons. These are nice big numbers. I get it. Okay, I'm just wondering if my vertical speed is... I'm just wondering when I should actually start firing these, ditching these things, let's say. And I'm not using time acceleration because we just know that that leads to pain and agony. And this is my last run before I hand it off to the rest of the world and ask them to do better. Okay, you know what? I'm gonna ditch this. And I probably should have done that while spinning, shouldn't I? Uh-oh, this may not work quite as well as I expected. Okay, you know what? I'm gonna do this. And then... oh, shoot! Okay, that didn't work. Okay, well, that kind of survived. Throttle up to maximum. I thought I was going to put these little engines on, but apparently I didn't. And also, apparently these few engines aren't firing. What's up with that? Come on, why aren't you firing? You're not helping me go down. Ah, there we go. Now we get more thrust, and unfortunately we're totally overshooting here. And also, we're not holding our position particularly well either. Come on. At least we're going downwards. We should pick up some real speed here. This will be interesting. I wonder if how the jet engine will work, to be honest. That is the real untested technology here. Oh, and spinning too fast. Okay. And liquid fuel is gone. And now I need to actually turn my spacecraft and point it downwards. Hopefully the engine in the tail will pull us straight. Okay, we're going... I don't think we're going as fast as in previous versions. I think there's a bunch of things I messed up here. I know I can optimize this somewhat better. Yeah, come on, 43... Can I get... I'm not going to get it under 3 minutes, but it'll be nice to see if that jet engine will actually make a difference. I could probably put a decoupler in here, that would have helped, but I think having this will... it'll actually help absorb the force of impact. That's really part of the idea here. So we're going to go down. Excellent. And that engine is firing up yet? Totally, so that's pushing us downwards, so our speed downwards should continue to remain high until we ditch the whole thing at about 500 meters maybe? We're going a little faster, but we're not going that much faster that it's worth necessarily all that extra mass slowing us down. Okay, 900, 800, 700, and... oh, darn, opened that a little early. All the same, I think that was somewhat successful and could be optimized. Yeah, ended up being slower. But still, it was more spectacular. So, prizes are... oh, yes. Oh, look at it go. I think that was actually a pretty good piece of technology. It just doesn't really develop enough thrust. Maybe I need to have, like... instead of that, just have a solid rocket booster that pushes me through the last section of the atmosphere or something. Or just a straight up. Maybe just have more fuel in that stage. Okay, so... I've managed to get this down to like 330. I might have a better version of this. Okay, so you've seen the crazy ideas, and I'm sure people will do better. So this is it. It's challenge time. If you think you can do better, make a video, post it, or just send me the craft and I'll fly it, right? I'm Scott Manley. Fly safe.